All right, so we are looking at determinants and Cramer's rule. So determinants are associated with arrays of numbers. And the definition of the determinant of a 2 by 2 matrix, the determinant of the matrix that looks like this is denoted by this and defined by this. So basically we're going to cross multiply this way and then subtract the cross multiplication of the other way. So let's go do some determinants. All right, so example 1, we're going to evaluate the determinant. So part A, we have a determinant of 5, 6, 7, and 3. And we're going to evaluate this. So all we're going to do is cross multiply 5 times 3 minus 7 times 6. You have to start up here and go down and then subtract and go that way. Now the numbers, as long as you get the two numbers correct, but don't do it backwards, the main thing. So this would be 15 minus 42, which gets you negative 27. Part B. So we have 2, 4, negative 3, negative 5. So we're going to do 2 times negative 5 minus negative 3 times 4. 2 times negative 5 is negative 10. Negative times a negative will get us a positive 3 times 4, which is 12. And 12 minus 10 will get us 2. Part C, if we have 10, 9, and 6, 5, we will have 10 times 5 minus 6 times 9. 10 times 5 will get us 50, minus 6 times 9, which is 54, which will get you negative 4. So that's all you have to do with those. So let's use the determinants and the Cramer's rule to solve some systems of linear equations. So this is what our system looks like, where we have our a sub 1, or our b sub 1, or c sub 1, a sub 2, b sub 2, and c sub 2. Our x is going to be the determinant over of x, the dx over the d. So this is the fancy way to look at it. And of course the determinant can't be 0 because it's in the denominator. So an easier way to look at it is that dx over d, so x will be equal to dx over d, and y will be equal to dy over d. So we're going to find the determinant of x and divide it by our determinant, and the determinant of y over the determinant. And I've got, we'll go through an example of that where it will make sense. So example 2. So example 2, we are going to use Cramer's rule to solve a linear system. So here is our system. We have 5x minus 4y equal to 2, and 6x minus 5y equals 1. And we need to understand that x is going to be equal to dx over d, and y will be equal to dy over d. So it's d sub x and d sub y. You can think about it, if I cancel out the z's, you can't really do that, but if you just look at it visually and go, oh, the d's cancel, x will equal x. Same thing would happen to here, y is equal to y. That might help you visually see what goes on top. my dx over my d. Don't flip them over. So that way you end up with x equal to x. It doesn't really happen quite that way, but visually you can look at it and maybe it'll help you remember. So let's go find the d. So d is going to be our determinant. So we're going to do this the same way we did the other one, and we're going to just use these first numbers. So our determinant is going to be 5, -4, and 6, -5. So we're still doing the same thing we did in the previous examples. 5 times -5 minus 6 times -4. Well, that's going to get us -25. Negative times negative over here will make this a positive 6 times 4, which is 24, which means our determinant is -1. Now we're going to do our d sub x, which is going to be a little bit different. So when you do this determinant, you're going to, instead of using the x coefficients, you're going to use the numbers on the equal sign to replace. So instead of using 5, we will use 2. Instead of using 6, we will use 1. But the other numbers will stay the same, so -4 and -5. So we do the same thing. 2 times -5 minus 1 times -4. 2 times -5 is -10. A -1 times a -4 will get us a +4, and we end up with -6. Now our d sub y, we are going to put the x's back the way that they originally were with the 5 and the 6, but we'll replace the coefficients of y with the coefficients or the numbers on the other side of the equal sign. So x will still be 5, 6, but this part here will be 2, 1. So this will be 5 times 1 minus 6 times 2, which will be 5 minus 12, which will get us -7. Now we can take these three values and solve for our x and y. So for the x value, our x will be equal to that d sub x over d. So that's going to be -6 over -1, which will be +6. And the y will be the d sub y over d, which is -7 over -1, which will be 7. So your answer is still an ordered pair. It is 6, 7 in parentheses for that ordered pair. All right, let's go do another example of Cramer's rule. So this will be example 3. We have 5x plus 4y equals 12, and 3x minus 6y equal to 24. So we need to find the d, the dx, and the dy. So our d will be starting out just like we did before. We'll have our 5, our 4, our 3, and our -6. So we have 5 times -6 minus 3 times 4. So that'll get us -30 minus 12, which will be -42. Our d sub x, remember we don't use these two, we're going to use these two, so we'll have 12 and 24, and 4 and -6. So 12 times -6 minus 24 times 4. So 12 times -6 will get us -72. And -24 times 4 is -96. And that will get us -168. And then we need to do our d sub y. So we're back to the x's being the original numbers, and now our y is 12 and 24. Those are the coefficients we're using. All right, so we have 5 times 24 minus 3 times 12. 5 times 24 will be 120 minus 3 times 12 is 36, which will equal 84. So now we need to find our d sub x, or our x. Our x will be equal to that negative 168 over negative 42, which will be 4. And our y will be equal to 84 divided by negative 42, which will be negative 2. So our ordered pair is going to be our x and our y in parentheses. All right, so that's the 2 by 2. We're going to go work on a 3 by 3, and we're going to solve using Cramer's rule. So this one will be a little bit more tedious. There is a different definition, but I've been taught there's an easier way to do this. And the definition of the determinant of a 3 by 3, you can do all the little determinants, but really what we can do is write the matrix, and then the determinant is going to be the matrix itself, and then repeat the first 2 rows. So you're just going to repeat them, and we're going to follow a diagonal. So as I do this, it'll become more clear. All righty. So let's start with example 4. So we're still using Cramer's rule. We're just doing a 3 by 3. So we have x plus 2y minus z is equal to negative 4. X plus 4y minus 2z is equal to negative 6. And 2x plus 3y plus z is equal to 3. So that's our 3 by 3 equation. Now we've got to figure out a determinant, the dx, the dy, and the dz. So let's start with our d. So d will be, we're going to do the same thing we did before. It's 1, 1, 2, because we have a 1, and a 2. 2, 4, 3. Negative 1, negative 2, and 1. And then we're going to repeat the first 2 rows. So 1, 1, 2, 2, 4, 3. Now we're going to do the same thing we did previously of cross multiplying, except we're doing it slightly different. So we're going to start with the top corner just like we did before. So we're going to have 1 times 4 times 1 is going to get us 4. So 1 times 4 times 1. So I'll write this out so you can see where it's coming from. So these 3 numbers. On the first part we're going to add, plus, then we'll have 2 times negative 2 times 2 plus negative 1 times 1 times 3. And then the next ones will get subtracted. So minus 2 times 4 times negative 1 minus 3 times negative 2 times 1 minus 1 times 1 times 2. So 1 times 1 times 2. Got a little small there, sorry about that. So 1 times 4 times 1 will get us 4. 2 times negative 2 times 2 is a negative 8. Negative 1 times 1 times 3 is a negative 3. 2 times 4 times negative 1 is a negative 8, but it's a negative 8, so that'll be positive 8. Negative 3 times negative 2 is 6 times 1 is 6. And then negative 1 times 2 will be minus 2. So the ones you go this way on, you add, and then when you go this way, you subtract all of those, just like we did previously on the 2 by 2. When we came down, we just put the number, and then we subtracted when we went up. So when I combine all of these numbers, we will get 5 for our D. So let's go do D sub x. So for D sub x, we're doing the same thing we did previously. We're going to replace the coefficients of our x with the values that are on the equation side. So we'll have negative 4, negative 6, and 3. And we'll have 2, 4, 3, negative 1, negative 2, and 1. Repeat the first 2 rows. And then we're going to cross multiply again. So we're going to have negative 4 times 1 plus 2 times negative 2 times 3 plus negative 1 times negative 6 times 3. And then we're going to subtract, we'll do it right here, subtract 3 times 4 times negative 1, subtract 3 times negative 2 times negative 4, subtract 1 times negative 6 times 2. So we're going in our diagonals again. You need to try and line your numbers up as well as you can so you can see the diagonal numbers going up across that way. All right, so negative 4 times 1 will get us negative 16. 2 times negative 2 times 3 will get us negative 12. Negative 1 times negative 6 times 3 will get us positive 18. Then negative 3 times 4 times negative 1 will get us a positive 12. And then negative 3 times negative 2 times negative 4 will get us a negative 24. And negative 1 times negative 6 times 2 will get us a positive 12. And when we add those, we should end up with a negative 10. So on the next one, on the Z part, I'm going to not write it all the way out. I'm just going to show you how you can do it a little simpler if you can do that math without writing out every little piece. So let's go do dy, because that's just D. Let's do dy. So for dy, we are doing the same thing. X is itself. So we have 1, 1, 2. Our y is now the values on the other side of the equal sign. So negative 4, negative 6, 3. And then our z's are the same. So negative 1, negative 2, 1. Repeat the first 2 rows. 1, 1, 2, negative 4, negative 6, and 3. Alrighty. So I'm going to just write the numbers as I multiply them. So 1 times negative 6 times 1 will get us negative 6. Adding negative 4 times negative 2 is negative or positive 8. 8 times 2 will be 16. Plus negative 1 times 3 will get us a negative 3. Minus 2 times negative 6 times negative 1 will get us 12. Minus 3 times negative 2 is negative 6 times 1 is a negative 6. Minus 1 times negative 4 will be a negative 4. So you don't have to write all of the numbers. you can just do the diagonal multiplication. When you add all these together, you should end up with positive 5. And these double negatives, of course, are going to be a positive number. All right, now we need to do dz. Got my equal sign there. All right, so dz, x's are the back to normal, y's are back to normal, and the z's are now changed with the numbers on the other side of the equal sign. So -4, -6, and 3. Repeat the first two rows. All right, so we have 1 times 4 times 3 will get us 12, plus 2 times -6 times 2 will get us -24, plus -4 times 1 times 3 is -12, minus 2 times 4 times -4 is -32, minus 3 times -6 times 1 will get us -18, minus 3 times 1 times 2 is 6. And when we add all those together, we should end up with 20. All right, now that we have our d, our dx, our dy, and our dz, we can find the values of x, y, and z. So we're doing it the same way we did on the previous problem. Our x, remember, is dx over d. dx was equal to -10. Our d was 5, so we end up with -2. Our y is equal to dy over d. dy was equal to 5 over d of 5 is equal to 1. Our z will be equal to dz over d, which is going to be 20 over 5, which will be 4. So we end up with an ordered triple of -2, 1, and 4. So that's our answer for that one. All right, let's do one more example. All right, so example 5. So on example 5, we have an ordered triple of 3x minus 2y plus z is equal to 16, 2x plus 3y minus z is equal to -9, and x plus 4y plus 3z is equal to 2. So we're doing the same thing we just did. We are finding all of our determinants, and then we'll do our division and solve for our variables. So the first one we're looking at is finding d. So we have 3, 2, 1, -2, 3, and 4, 1, -1, 3. Repeat the first two rows. Sorry, first two columns. They are columns, not rows. 3, 2, 1, -2, 3, and 4. Sorry about that. They are columns, not rows. All right. So we're going to do this one the same way we did the y and the z on the previous one. We have 3 times 3 times 3, which will get us 27, plus -2 times -1 times 1 will be 2, plus 1 times 2 times 4 is 8. Minus 1 times 3 times 1 is 3. 4 times negative 1 times 3 is going to be negative 12 minus 3 times 2 times negative 2. And that will also be a negative 12. And when you add those together, you should end up with 58. All right, let's go do our d sub x. So we're going to replace our x coefficients with the parts on the equal side, and then negative 2, 3, and 4, and 1, negative 1, 3. Repeat the first two columns. 16, negative 9, and 2, negative 2, 3, and 4. All right, so 16 times 3 times 3 will get us 144 plus negative 2 times negative 1 times 2 is positive 4 plus 1 times negative 9 times 4 is negative 36 minus 2 times 3 times 1, which is 6, minus 4 times negative 1 times 16, which will be negative 64, minus 3 times negative 9 times negative 6, which is 54. And that will add up to be 116. All right, let's do dy. So d sub y, x's go back to what they were originally, so 3, 2, 1. The y's are now 16, negative 9, and 2. And then our z's, 1, negative 1, and 3. And repeat the first two columns. So 3, 2, 1, 16, negative 9, and 2. So 3 times negative 9 times 3 will get us negative 81 plus 16 times negative 1 times 1 will be negative 16 plus 1 times 2 times 2 is 4 minus 1 times negative 9 times 1 is negative 9 and minus 2 times negative 1 times 3 will be negative 6 minus 3 times 2 times 16 will get us 96. And when we add those together, we should get a negative 174. All right, let's do our dz. So our dz, our x and y's are the originals. So 3, 2, 1, negative 2, 3, 4, and z is now the 16, negative 9, and 2 from the other side of the equal sign, and repeat the first two columns. All right, so 3 times 3 times 2 will get us 18. Negative 2 times negative 9 times 1 will get us 18. Plus, we have 16 times 2 times 4, which is 128, minus 1 times 3 times 16, which is 48, minus 4 times negative 9 times 3, which will be negative 108, minus 2 times 2 times negative 2, which will be negative 8. And when we combine those together, we will get 232. So now we just need to find our x, y, and z. So our x is going to be dx divided by d, which will be 116 divided by 58, which equals 2. Our y is dy divided by d, which is negative 174 divided by 58, which will equal negative 3. And our z will be dz divided by d, which will be 232 divided by 58, which will be 4. So our answer is 2, negative 3, 4 in an ordered triple, because that is your final answer, and it needs to be in that triple.